Hello, students. I want to share with you today some information about how to write formulas for the transition metals. And also, I want to talk about what happens when atoms share electrons rather than transfer. So we're still talking about, with the transition metals, we're still talking about ionic bonding. And that means that electrons are transferred, not shared. Electrons are transferred, okay? So the transition metals are the ones on the periodic table that are kind of down there in the valley of the periodic table. So they're in through here, okay? And you learned that group 1 has a charge of +1, group 2 is +2, group 13 is +3, and so on. And then we don't have 14, group 14 doesn't have a charge. But then we have -3, -2, -1, okay? And then we have the noble gases over here. Okay, so the transition metals are in through here, and we didn't label them with any charges at all. And that's because they can have various charges. And that's because they're filling the D subshell. I don't need you to worry about that very much right now. But what that means is they can have various ionic charges. So something like copper, okay? Copper can be copper +1, but it can also be copper +2. So when it forms a compound, when copper +1 forms a compound with chloride, you would need one of each, just like before with the crisscross method, and that would be copper chloride. Okay, but we need to specify that it has this charge of +1. And so when we give it a name, we say copper Roman numeral 1 chloride. And the Roman numeral stands for the charge on the copper, not how many, but the charge. When we think about this copper +2 ion, okay, it's a different compound, different color, combining with chloride. From the crisscross method, you know that that would be copper Cl2. A different, look here, the formulas are different. And so when we name it, we would say copper, and in parentheses, Roman numeral 2 to indicate the charge on the copper chloride. Okay, the stock system, that is the stock system. And the stock system uses Roman numerals to indicate the charge on the metal. Not on the non-metal, just on the metal, the stock system. Okay, let's do another one. Let's say that we've got iron +2, these are the common oxidation states, and iron +3. Let's combine each of those with chloride again. So iron +2 and chloride. Chloride is always -1. And I think you know from some of your practice now, you would have FeCl, Cl2. All right, so we would name that iron. Again, we use the charge as a Roman numeral, and then we write the nonmetal, okay? The Roman numeral is the charge on the metal, not how many. It is not quantity. Okay, iron +3 with chloride then, I think you can guess that's going to be FeCl3 and iron 3 chloride. Again, I'm going to say it again, okay? The Roman numeral is the charge on the metal, not how many. It does not indicate how many ions. All right. Let's move on quickly to molecular naming, the easiest of all of them. And that is not a matter of electrons being transferred. That is the sharing of electrons. And we're not going to go into what that structure looks like right now. We're just going to name them for today. So let's look at something like CO, CO2. You already know what those are. Carbon monoxide and carbon dioxide. You know that from biology. So with molecular substances, because they don't transfer electrons and because they can have various oxidation states, we use prefixes to say how many atoms. Okay, so there's your prefix of mono, there's your prefix of di to indicate two. So if the first atom is one, let me put that right here. If first atom or the first element is one, you can skip using the prefix mono on the first element. Okay, let's look at a couple different ones. Let's look at NO2, okay? Nitrogen dioxide. What if it was NO3? Nitrogen trioxide. Here's one where the nitrogen is not a one, so we would need the prefix dinitrogen trioxide. That's it. Molecular is really, really easy. So the prefixes are mono, di, tri, tetra, penta, hexa, hepta, octo, and nona. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's it. Okay, that's it for molecular. Now, when you're naming these and you've got them all put together, we have a lot to remember. We have ionic and we have molecular. Molecular was the last one we just did. It's pretty easy. That's when you have a non-metal bonded to a non-metal. Very, very important, okay? Electrons are shared. Ionic, you have cations and anions. Even easier, excuse me, is you have a metal to a metal to a non-metal. And electrons are transferred. Don't forget that with ionic, you're going to have some polyatomic ion compounds, and you're going to have the stock system with those transition metals. Molecular, you're just going to use the prefixes. I hope this helps.